you take a look, you have to be in standard form. So the A, the B, and the C are coming from standard form. You also have to be equal to 0 right here. My screen is like, does that look blurry to you? Does that look blurry? Oh, there we go. Is that like you just put on your glasses and now it's clear? Okay, perfect. Okay, so I want to solve one by factoring and prove to you that the quadratic formula will work. So let's do this one by factoring one more time. How would I factor this? Should I use greatest common factor? What strategy should I use for this problem? I don't need the box. I'm going to do the diamond, right? It's a trinomial. So I'm going to do 2 parentheses. They both get an x. I'm going to think about factors of 15 that add up to -8 to put inside my factors. So what would I put? So what are my factors? What are the factors of 15? Yep, so -3, -5, +15. X minus 3, x minus 5. What would be the solutions to this quadratic? What are my x-intercepts? 3 or +5. Okay, I want to prove to you that if you use the quadratic formula, you're going to get the exact same answer. And those of you that have been struggling with factoring, if you can't factor it with factoring, you could use the quadratic formula and almost like backdoor factor it. So I'll show you how you could take your solutions and figure out the factors. All right, so I like to label what is A, B, and C in this problem. So this is resource page 310. Should all be filling in. What's A in this problem? Nope, A goes in front of x squared. So what number is in front of x squared? A 1, right? That's a 1. So A is 1. B, you said, was -8. And C is 15. You only use the coefficients. You don't use x. So now I'm going to put it into the formula. The formula says x equals, all right, opposite of B. What's the opposite of -8? +8, right? Plus or minus the square root. What is B squared? What's -8 times -8? So +64, because a negative times a negative is a positive. So the opposite of B, plus or minus the square root of B squared minus 4AC. So -4 times A is 1 times C is 15. And then all over, so that whole thing is over. What is 2 times A? We're on page 310. 3-10. Oh, I forgot. We were going to go back and do number 12, and I never did. But I have to do 2A. So 2 times 1 is 2. You okay with setting that part of it? Oh, you did too? Oh, I did. Oh, you did too? Oh, you want any other one? Okay. All right, so I need to evaluate that using order of operations or a calculator, but it's just as easy, almost without a calculator, typing it all in. So under the square root symbol, what does that simplify to? What is 64 minus 60? Because 4 times 1 times 15 is 60. So what's 64 minus 60? Right? This all together is 60. So I get 4 under the square root. So 8 plus or minus the square root of 4 over 2. Oh, good. Sure, that'd be great. So what's the square root of 4? 2. So I need to do 8 plus 2 and divide by 2, and 8 minus 2 and divide by 2. And whatever those two fractions simplify to are going to be my two solutions. What's 8 plus 2? 10. What's 10 divided by 2? 5. And what's 8 minus 2? 8 minus 2 is 6. And what's 6 divided by 2? Did I get the same answers that I got by factoring? Didn't I get 5 or 3? Both ways, by factoring and by the quadratic formula? So let's pretend I didn't know how to factor this. So I was telling people, Zach, before you came in, Like if you're struggling with factoring, but you know the quadratic formula, you can still figure out what the x-intercepts are, and then figure out, all right, well, what did the factors have to be so that 5 or 3 were the solutions? One of them had to be x minus 5, so that 5 would be a solution, right? And the other factor would have to be x minus 3, so that 3 was the solution. So it's kind of like backwards factoring. So if you get really stuck on a question, it won't work every time, especially when you have like, a 3x plus 1 and an x minus 8. It's a little bit harder to figure that factor out, but at least you could get to the solution and then try to do, the factoring or something. Okay, so that's the quadratic formula. Oh, yeah. Go for it. Oh, was it a paper? We're good then? Okay. Are you good with that? Can I turn the page? Okay, I just wanted to show you on the back page, like why would you actually want to use the quadratic formula when something's not factorable, right? When your x-intercepts are something like this, and you have no idea where those x-intercepts are because they don't hit on an integer. So you actually do need the quadratic formula like once in a while if I give you a problem that's not factorable. So let's do one more together like this. So you set it up as A, B, and C. So what's A, B, and C in this problem? A is -1 this time. B would be -7, and C would be +3. I should just take a glance that I have 0 on the right-hand side. If I don't have 0 over there, I need to get 0. But all right, so I do the opposite of B. So -7 turns into, so the opposite of B plus or minus the square root of, what's B squared? So B times B. -7 times -7. B squared. So -4 times A times C. I just put those all in there. And then all over, what's 2A? 2 times A this time. 2 times -1? -2? All right, let's say you're not really good with mental math. You want to use a calculator. You don't want to start by typing this whole thing in. What I would do is I would just focus under the radical. I can see that this is going to be 49 plus 12. Maybe you can't. I know that -4 times -1 times 3 is +12. I would just type 49 plus 12 in. But if you can't do that mental math, you're going to take 49 minus 4 times -1 times 3, and that will tell you it's 61 under the radical. So I would have 7 plus or minus the square root of 61 divided by -2. Then if you wanted to go further to find the decimal, you could actually type, 7 plus the square root of 61, hit enter, divide by -2, and get -7.41, or then I would have to do it again. 7 minus the square root of 61 divided by -2.41. So if you want to find the decimal equivalent because you're graphing it, or you have to figure out how many units of something you had, how many shirts did the person buy to maximize their profit, or where did the ball hit the ground after how many seconds? Otherwise, this is reduced radical form because it's a square root of 61 with that fraction. So, okay, so that's the quadratic formula. It's going to take a lot of practice, which we'll do some practice tomorrow, I think. So the quadratic formula has something called a discriminant. So the last resource page is, what is this discriminant talking about? The discriminant is just what's under the radical. So it's just b squared minus 4ac. So on your test, I will give you this entire quadratic formula right here, but you're going to have to know that the discriminant is just this part underneath, that it's b squared minus 4ac. That's going to tell you how many solutions you have on your graph. So remember we talked about how many solutions there are? Like there's one solution to that quadratic, or there's 0 solutions to that is a formula, this will also tell you how many solutions there are. So this says find the discriminant of each of the following equations, and then if you notice, their graph is down below. So this A goes with this graph, B goes with this graph, and C goes with this graph. So we're going to find the discriminant. So what is B squared minus 4AC for each of these problems? This will get you good at the quadratic formula. What's B squared for part A? -6 times -6 is what? Positive 36. Minus 4, what's A in this problem? 1. And what's C in this problem? 9. Well, isn't this 36 minus 36? Because 4 times 9 is 36. How much does that equal? 0. So hypothetically, can you take the square root of 0? You can, right? The square root of 0 is just 0, because 0 times 0 is 0. So when the discriminant comes out to 0, let's take a look at this graph. How many solutions are there on this graph? There's only one solution, right? So we're going to make a rule for this at the end. That's the thing. When I take the square root of 0, I get 0. There's one exponential on the graph. Okay, let's do the next one. This one's a little bit tricky because you're missing one of your terms. What is B in this problem? Right, there are 0 x's, right? B is 0. Minus 4. What's the A value in this one? In part B, what is the A value? 1. And what's the C value? 2. And what do I get when I take 0 and subtract 4 times 1 times 2? What is 4 times 1 times 2? Yep, so I get -8. Can you take the square root of a negative number? No. How many solutions do you notice are on the graph below? So there are 0 solutions. I should say there's one solution. Okay, so when you square root of a negative number, that kind of makes sense. There would be no solutions on the graph. All right, and let's do this last one. So I want you to figure out B squared minus 4AC this time. See if you can plug in the values and get part C. What number would you get? Okay, so B squared, that's 4 squared, right? 4 times 4 is 16, minus 4 times 1 times 3. 4 times 3 is 12, so 16 minus 12. 4. Can you take the square root of a positive number? Yes. And think about your equation. Yep, it's going to be plus or minus the square root. When you take plus or minus 0, doesn't do anything. But if you take plus or minus the square root of 4, you're adding 2 and you're subtracting 2, so it changes and you get 2 solutions. So if you notice on the graph, you have 2 solutions on your curve. So can we summarize this down below? If the discriminant comes out to 0, that's that first situation, right? The square root of 0 is 0, but plus or minus 0 gives me the same number. So that's why there is one solution. If the discriminant is negative, there will be no solution. And if it's positive, there will be 2 solutions. And you don't have to memorize this. It's just supposed to be a shortcut. Like if you get that this is the square root of 4, whatever B was, I forget what it was. Let's say it was 7 plus or minus 2. That's going to be 2 different numbers, right? 7 plus 2 is 9, but 7 minus 2 is 5. So you get 2 different solutions. Okay, last but not least, I want to see if you can just do a quadratic formula problem or 2 on your own. So even if you only get like 1 or 2 of them done, This is page 308. I'd love for you to try 1, 2, 3, and 4. I think one of them has like no solution. So it would be good to see what does it look like when something has no solution. Do you feel like you need to do one more together on page 308, or do you think you can use the formula? I'm going to put the formula up on the board so you don't have to keep flipping back and forth, because that will be printed for you on a test. You just can't stay away, can you? You like can't even get to my room. You can't wait to leave my room and walk toward it. Yeah. Maybe it's just the folks in there. That's going to be plus minus 30, minus 40, all which way. I'll let you say if you see the top goes legal. One thing over there.
No, please make them. It'll be so.
Okay. Does anybody want to try one more together? What? Well, sorry, I got a little sidetracked on number 1, so I put up the whole problem. But it really was what? That number 1 had a discriminant that was 0, so there's one solution. Number 2 came out as 108, so it had 2 solutions. Number 3 was negative 392, so it had 0 solutions. And number 4 was 52, so it had 2 solutions. And then we're going to do a little bit of practice on that tomorrow and next week. So this is like the 7th little piece in your bucket of solving quadratic.